Automated manual transmission. Automated manual transmission (AMT), also known as a clutchless manual, denotes a type of multi-speed motor vehicle transmission system that is closely based on the mechanical design and build of a conventional manual transmission, but uses automation to operate either the clutch and slash or the gear shifting. Many early versions of these transmissions that are semi-automatic in operation, such as Autostick, can only control the clutch system automatically, often using various forms of clutch actuation, such as electro-mechanical, hydraulic, pneumatic, or vacuum actuation, but still require the driver's manual input and full control to initiate gear changes by hand. Modern versions of these systems that are fully automatic in operation, such as Selespeed and Easytronic, can control both the clutch operation and the gear shifts automatically by means of an ECU, therefore requiring no manual intervention or driver input over gear changes. The usage of modern computer-controlled AMT in passenger cars increased during the mid-1990s as a more sporting alternative to the traditional hydraulic automatic transmission. During the 2010s, AMT were largely replaced by the increasingly widespread dual-clutch transmission design and operation. Automated manual transmissions can be semi-automatic or fully automatic in operation. Several different systems to automate the clutch and slash or shifting have been used over the years, but they will generally use one of the following methods of actuation for the clutch and slash or shifting: hydraulic or electro-hydraulic actuation, electro-mechanical, pneumatic, electromagnetic, or even purely electrical by means of an electric motor. Gear shifting, clutch actuation, shift timing, and rev matching are all under automated control via the electronic sensors, computers, and actuators. When shifting gears, the driver selects the desired gear with the transmission shift lever, while electronic sensors and actuators connected to a TCU transmission computer or microprocessor will automatically operate the clutch and throttle to match revs and to re-engage the clutch in milliseconds. Torque and power transfer to the drive wheels will also be electronically controlled. Most modern implementations of this transmission function in a sequential mode, where the driver can only upshift or downshift by one gear at a time. However, this is not the case for all modern transmissions. For example, BMW SMG and Ferrari's phone transmission can skip gears on both downshifts and upshifts when selecting gears manually via the steering wheel-mounted paddle shifters, as seen on most modern transmissions. Older clutchless manual transmissions, mostly prior to the 1990s, will retain H-pattern shifters plus the shift gate and will require the driver to select the required gear ratios manually. The clutch, however, will be a servo-controlled unit connected to various actuators, a solenoid, and sensors which control the clutch automatically. Another alternate means of clutch automation is the clutch-by-wire system. The system generally uses an electric actuator and electronic sensors, which replace the mechanical clutch linkage or hydraulic clutch connection, to monitor and control clutch positioning, completely replacing the hydraulic linkage between the mechanical clutch and pedal itself with a single electro-mechanical actuator. Depending on the mechanical build and design, some mostly modern automated manual transmissions will automatically shift gears at appropriate points like a conventional automatic transmission, while traditional semi-automatic and clutchless manuals require the driver to manually select the gear even when the engine is at red line, since they only automate part of the transmission, namely the clutch, and will not shift gears by themselves. Despite the superficial similarity, automated manual transmissions differ significantly in internal operation and driver's feel from a pneumatic, the latter of which is an automatic transmission. Automatics use a torque converter instead of a clutch like in an automated manual to manage the mechanical linkage between the transmission and motor, with the ability to override the automatic transmission's computer and actuate shifts manually. Add-on AMT can also function as a regular manual gearbox with a manual shift lever, whereas integrated AMT do not need a normal shift layout, so they can be designed with an optimized AMT shifting layout, which would have an unusual pattern to manually shift. Integrated AMT either have gear selector drums, which only allows serial shifting and no gear skipping, but this system is fairly inexpensive because it needs only one actuator, or single actuators. Single actuator systems require one actuator for each shifting sleeve, which is why this type of system is more expensive. The actuators can either be electro-hydraulic, more expensive, but faster, well suited for single actuator systems, and allow for higher torque, or electro-mechanical, less expensive, but usually limited to 250 and M184. 5 lb-ft of gearbox input torque. This limit is because the clutch actuation force increases with higher torque and short shifting times. Electromechanical actuators are just electric motors. Using larger motors reduces the motor dynamics due to the motor's higher mass moment of inertia, which is not good for fast shifting, and bigger motors also put more stress on the car's 12-volt electrical system. A result, one can have either slow shifting and a very large lead-acid battery not suitable for cars, or fast shifting and a smaller battery works up to 250 N*M of torque. Usage in passenger cars. The automated manual transmission has its origins in early clutchless manual transmissions that began to appear on mass production cars in the 1940s and 1950s. An early example of this transmission was introduced with the Hudson Commodore in 1942, called Drive Master. This unit was an early semi-automatic transmission based on the design of a conventional manual transmission, which used a servo-controlled vacuum-operated clutch system with 3 different gear shifting modes. At the touch of a button, manual shifting and manual clutch operation, fully manual, manual shifting with automated clutch operation, semi-automatic, and automatic shifting with automatic clutch operation, fully automatic. Another early example is the 1955 Citroën DS, which used a 4-speed BVH transmission. This semi-automatic transmission used an automated clutch, which was actuated using hydraulics. Gear selection also used hydraulics. However, gear ratio needs to be manually selected by the driver. In 1956, Renault Dauphine 3-speed manual transmission was available with an optional Furlec automated clutch, which used an electromagnetically operated clutch system. Other clutchless manual transmissions included the 1967 NSU Row 83 Speed Fischl and Sachs and 1967 Porsche 911 4-speed Sportomatic, both of which used vacuum-actuated clutches and hydraulic torque converters. In 1968, Volkswagen Beetle and Volkswagen Carmen Gaia offered a 3-speed Autostick transmission, which used an electric switch on the gear shifter connected to a solenoid to operate the electro-pneumatic vacuum clutch servo. In 1963, Renault switched from the automated clutch to a fully automatic 3-speed Jaeger transmission, which consisted of an electromechanical control unit that operated both the clutch and shifting, effectively making it one of the earliest automated manual transmissions. The Jaeger transmission was controlled via dash-mounted electronic push buttons. The Isuzu NA-VIFIV 5-speed automatic transmission was introduced in the 1984 Isuzu Aska midsize sedan, sold in the Japanese domestic market only. This transmission, originally designed for trucks, was based on a manual transmission with the addition of hydraulic actuators for the gear shifter and the clutch. Initial versions did not allow direct selection of gear ratios, instead only allowing drivers to lock out higher gears as per many traditional automatic transmissions. Later versions added a manual mode, allowing the driver to control the gear selection. Several companies owned by Fiat S.p.A. were influential in the development of automated manual transmissions. Ferrari's involvement with automated manual transmission began with the 7-speed, semi-automatic paddle shift transmission used in the 1989 Ferrari 640 Formula One racing car. In 1992, the Ferrari Mondial T introduced the option of a Valeo 5-speed semi-automatic transmission. This transmission used an electro-mechanical actuator to automatically operate the clutch, while the gearshift mechanism was a standard H-pattern shifter operated as per normal transmissions. In 1997, the Ferrari F355 became available with an Phone 6-speed transmission, which uses paddle shifters located behind the steering wheel or can be driven in a fully automatic mode. The F355's successors offered similar transmissions until the company switched to a dual-clutch transmission for the Ferrari 458 in 2009. Sister company Alfa Romeo introduced the related Selespeed 5-speed automatic transmission for the Alfa Romeo 156 in 1999. This was followed by Maserati's 2001 introduction of the related Cambio Corsa 6-speed automatic transmission in the Maserati Coupe. Selespeed was also used in the Fiat Punto and Stilo models. BMW involvement with automated manual transmissions began in 1993, when the Shift-tronic 6-speed semi-automatic was offered on the Alpina B12 Coupe based on the E31 850 CSI. Using an automated clutch paired to a standard H-pattern shifter, as per the Ferrari Mondial T, the transmission was supplied by Liu K and fitted to less than 40 cars. Mass production of automated manual transmissions began for BMW in 1997 with the introduction of the SMG 6-speed automatic transmission in the BMW E36 M3 Coupe. Although the name SMG was an abbreviation of sequential manual gearbox, the transmission internal were as per a typical synchronous-equipped manual transmission, not a true sequential manual transmission. The SMG was replaced by the SMG Roman II when the F46 M3 was introduced in 2000. BMW final AMT before being replaced by a dual-clutch transmission was the 7-speed SMG Roman III used in the 2004-2010 BMW S60 M5 and related BMW S63 M6. The SMG Roman III could achieve a shift time of 65 milliseconds in its most aggressive mode from 2002 to 2007. The Toyota MR2 third generation was available with an SMT 6-speed automated manual transmission. The SMT system utilized an electro-hydraulic activation system for both the clutch and shifting, but no H-pattern shifter like with the standard transmission. Instead, there was a shift lever that could be pulled and pushed forward or backward to upshift and downshift. Brands within the Volkswagen Group have typically used dual-clutch transmissions instead of automated manual transmissions. However, a 6-speed e-gear automated manual transmission was introduced for the 2004 Lamborghini Murcielago and Lamborghini Gallardo. The e-gear was used on the successors to the Murcielago and Gallardo, and it was also available on the 2007-2012 Audi Rate Type 42, marketed as the R-tronic transmission. Applications: usage in semi-trucks/tractors. Volvo I-Shift, an automated manual transmission, introduced in 2001 and used in trucks and buses. This system, is an add-on for the conventional unsynchronized manual transmission. Selespeed, an automated manual transmission, introduced in 2003 and used in trucks, buses, and coaches. Eaton Auto Shift, introduced in the early 2000s as an add-on to traditional non-synchronous manual transmission for heavy trucks. Mack M-Drive and M-Drive HD, an automated manual transmission with synchronizers, introduced in 2010 and used in Mack semi-trucks. Renault OptiDriver, an automated manual transmission, introduced in 2004 and used in Renault heavy-duty commercial semi-trucks. Daimler Trucks DT12, an automated manual transmission, introduced in 2012 and used in the Freightliner Cascadia semi-truck and the Western Star 49X line of commercial semi, crane, and dump trucks. Mercedes-Benz Power Shift, a non-synchronous automated manual transmission used in Mercedes-Benz heavy-duty semi-trucks. Trucks Escort, an add-on for non-synchronized and synchronized manual transmission, introduced in 1995. 6 different versions of this transmission have been made: Escort, Escort Roman II, Escort Roman III, Escort Roman IV, Escort V, and Escort VI. Used in UD Trucks range of commercial vehicles.